Here we go, 144 pi. Oh, and they give me the units as centimeters squared because that's area. Next problem is number 15. Number 15 says a sphere, so that's a keyword, a sphere with my volume is going to be 45 pi. I'm not going to use this number. I'm going to use a different one. Where's my problem for number 15? I tried one set of numbers. It didn't come out very well, so I'm going to use a different set of numbers. Here we go. The volume is going to be 36 pi feet cubed, cubic feet, and I want to find the radius. I use some really nice numbers here so that you can get some real nice wholesome numbers. Read the question again. A sphere with a volume of, I used the same numbers, 36 pi cubic feet and has a radius of how many feet? So the volume of a sphere is equal to 4/3 pi r cubed. Plug in the number, 36 pi is equal to 4/3 times pi times the radius cubed. Notice that the pi's cancel because it's divided by pi. A lot of students here at this stage would like to divide by 4/3. Dividing by 4/3 is the same thing as multiplying by 3/4, which is the reciprocal. So to get rid of the 4/3, instead of adding another step, I'm just going to multiply it by 3/4. That's how you get rid of the 4/3, because you're multiplying also the right side by 3/4. That's how you get rid of it. Notice something special. The 4's cancel with the 36. It becomes a 1 and a 9. 9 times 3 is 27. So r cubed is equal to 27. And take the cube root of that. R is equal to 3. I'm going to take a little bit of step extra. The inverse operation of cubing is cube rooting. The inverse operation of cubing is cube rooting on the right side. Cube root of 27 is 3. If you have any questions on this, let me know. 3 times 3 times 3 is 27, so that's the reason why the radius is 3. Next question. I did, which problems did I do after this? Here we go. I did number 16. Number 16 says a sphere of area, so it's a sphere again. Area is equal to 9. I used some different numbers. I used 25 pi. And this time I used micrometers. Micrometer is extremely small amount of distance. It's about the thickness of a hair, so it's an extremely small distance. I would like to find the volume. Read the question again. A sphere with an area of 25 pi micrometer has a volume of what? That's what I'm looking for. So that's the keyword sphere. I'm looking for the volume. I need the volume formula. Volume is equal to 4/3 pi r cubed. That's what I'm looking for. I don't have the radius, so I have a big problem. This is the type of question that will come out on a lot of your test questions, so make sure you get this problem especially down. They might give you the volume, you have to find the area. They might give you the area, find the volume, back and forth. So the volume, the surface area of a sphere is equal to 4 pi r squared. Oh, I have the area. I need the radius. 25 pi is equal to 4 pi r squared. the pi's cancel because I'm dividing by pi to both sides. To solve for r squared, I divide it by 4. R squared is equal to 25 over 4. And from here, I'm going to use purple this time. How do I solve for r? I take the square root of the left side and the right side. The square and the square root inverse operation cancels. The radius is equal to 5 over 2. The square root of 25 is 5. The square root of 4 is 2. Now I can plug this information into here, because that's what I'm looking for, the volume. It's going to be 4/3 times pi times 5 over 2 cubed. 5 over 2 cubed means 5 halves times 5 halves times 5 halves. 5 times 5 times 5 is 125 over 2 times 2 times 2 is 8. Does any of these cancel? 3 and the 5 don't cancel. 4 and the 8 cancels. So 2. Notice that the pi, is it in the denominator or the numerator? If you're not quite sure, just put a over 1 so that we know that it's going to be in the numerator. And get used to, if there's a number or a factor just representing itself, it's always in the numerator. So the volume becomes 1 times pi times 125 is 125 pi over 3 times 1 times 2 is 6. It's going to be micrometers cubed. And that's your volume. Very small amount of volume. Next problem. I did number 17 with a little bit different numbers, I believe. Well, I'm not sure if I used the same numbers. A cone. Oh, we have a cone this time. Has a radius. I used the radius is equal to 24 centimeters. Height is equal to 28 centimeters. And there's another cone with the radius. I'm going to use some different numbers. Let's use some different numbers this time. Let's use 40 centimeters. And the height is equal to 92 centimeters. I want to see if the first cone with the radius of 24 centimeters had the height of 28 centimeters, and the second cone with the radius of 40 centimeters and the height of 92 centimeters to see if they're similar or not. Well, that's what I'm looking for. Are they similar? If they are similar, then the ratio of the sides are always in proportion. Again, let me say that. The ratio of the sides equals the ratio of the sides. And that's called a proportion. A ratio equal to a ratio is called a proportion. So, I'm going to see if these two are in proportion. I'm going to go 24 over 28. Does that equal? That's a ratio. 40 over 92. Well, here, divided by 4, I get 6. Divided by 4, I get 7. You can use the pause button to try to figure out for yourself, because I might be going a little bit too fast for you guys. If I'm going at a pretty good pace, just follow on. Okay. Divided by 2, that's going to be 20. Divided by 2, that's going to be 46. Divided by 2 again, it's going to be 10. It's going to be 23. I know that 23 is a prime number, so therefore this fraction does not reduce. 6, 7 does not equal 10 over 23. The answer is no. Again, I put a question mark. Do they equal it? Next question, 20. I did number 20. The reason is because it's a good question, good test question. Did I use the same numbers that they did? Yes, I did. Two similar cones, so similar cones, have lateral area of 3 cubic centimeters, or square centimeters, excuse me, and 48 centimeters squared. Okay. What is the ratio of the volume? And that's what I'm looking for.